So for years, we've kind of operated under this pretty comfortable assumption about emotional intelligence, EI.
Hmm.
We treat it like a soft skill, right? All about empathy, social cues, managing feelings.
Yeah, it's the standard view.
But today, we're digging into some specialized sources that are really challenging that. They're saying EI is anything but soft. It's hard science.
Oh, absolutely.
Yeah.
That's almost putting it mildly. Our mission today really is to pull EI out of the sort of HR department mindset
Okay.
and place it squarely in, like, the neuroanatomy lab. We're moving beyond just the psychological side.
Right.
We're exploring frameworks like learnography and the brain page theory and focusing on how emotional control is actually redefined as a scientific neuromotor process.
Neuromotor.
Yeah.
Yeah.
Tied directly to learning, knowledge transfer, and crucially, physical performance optimization.
And this is really key for you, the listener, to get this dive is going to show how emotional control isn't just about, handling social stuff better.
No, not at all.
It's about actual physical brain function, measurable focus, the ability to execute complex tasks, especially under pressure.
Exactly. If you can physically train yourself to stay calm, your performance improves measurably.
We're going to try and map that process right onto your central nervous system. Okay, let's unpack this.
Let's do it.
So the core insight here, from these sources anyway, is this idea that emotional intelligence, it has to be understood as a neuromotor process.
Right. A literal mechanism
Okay.
in the brain
Okay.
that controls focus, keeps motivation going, and directs the physical actions needed to turn a thought into reality, into action.
Knowledge transfer, basically.
Yeah. So to really grasp this, we need to quickly define a couple of key terms from these sources. First, there's learnography.
Renography. Okay.
This isn't just, standard behavioral psychology. It's the dedicated study of the deep physiological link between emotion, specific behaviors, and motor learning.
In the brain.
In the brain, yeah. It essentially treats learning as a physical act.
Okay, physical act. And then there's the brain page theory. That one sounds, well, pretty academic. How is that different from just saying, I learned something?
That's a really good question, because the difference is critical here. The brain page theory argues that true knowledge isn't just memorized facts floating around. It's a physical ability to do something with that information. The sources define knowledge transfer as happening only when sensory input gets converted into motor output.
Motor output, like actually performing an action.
Exactly. Knowledge is kind of useless unless the learner can act on it.
Mm-hmm.
And here's the twist. Emotions are framed as the physical guides.
Guides.
Yeah, they determine if that conversion, that performance, actually happens successfully. It's all about building knowledge for performance, not just like storage.
Wow. Okay, so what I find fascinating here is the sources seem to be saying the same brain circuitry that helps you learn to ride a bike is also involved in managing your temper when things go wrong.
That's the core argument, yes.
So managing emotions isn't some vague psychological exercise anymore. It's a neurological process wired directly into the motor science of how we perform tasks.
Precisely. And if we accept that motor science view, well, the whole concept of discipline gets flipped on its head.
Right, because we usually think of discipline as external, don't we? The teacher telling the student focus or the rules at work.
Exactly, external control. But here, these sources argue that real emotional discipline, it arises internally.
Internally, how?
Through the brain's motor control systems, over the brain itself, the body, and behavior. They define it as the ability to regulate those strong, effective responses. Panic, frustration, anger, and just sustain a calm focus, even when everything outside is chaotic.
So it's an internal regulator.
An internal, motor-driven regulator. And crucially, the sources really stress this. This regulation is a motor function. It's not presented as a moral act.
Not about being good or bad.
No, it's about being physically controlled, neurologically controlled.
Okay, so if this emotional control is a physical motor function, where? Where in the brain do the sources say this management is actually happening? Which bits light up when we, manage to keep our cool?
We're talking deep motor learning centers.
Yeah.
The sources pinpoint the substantia nigra and, very importantly, the basal ganglia.
The basal ganglia. Okay, for listeners who maybe haven't brushed up on their neuroanatomy lately, what do those areas typically do?
Right. Think of the basal ganglia as the brain's like its autopilot system.
Autopilot.
Yeah. It handles the smooth execution of learned automated actions,
Yeah.
things you do without thinking consciously about every single step.
Like walking, or I don't know, driving a familiar route.
Exactly. Or a musician playing a practice piece, or an athlete hitting a ball. Skills that become automatic.
Okay.
So by linking emotional regulation to the basal ganglia, these sources are making a pretty bold claim. They're saying emotional discipline can, and maybe should, become an automated seamless skill.
Just like driving becomes automatic.
Just like driving.
Yeah.
It moves that emotional stability from being a constant conscious struggle
Which it often feels like.
to being more like a physical default setting, a trained automatic response.
That really makes the connection between that internal state and actual external performance feel, well, concrete.
Yeah.
But how do you train that emotional autopilot? Does it just happen over time?
Well, not passively, according to this framework. You train it actively,
Yeah.
like a muscle, using a specific process they call cycloside rehearsal, TCR.
Cycloside rehearsal. Okay,
Yeah.
what is that exactly?
It's described as a process of thalamic repetition of tasks, the thalamus being a key relay station for sensory and motor signals and alertness.
Right.
So the brain repeatedly cycles through all necessary steps for a specific task or knowledge transfer.
Yeah.
And crucially, that includes managing the emotional response associated with the task.
So it's not just practice makes perfect in terms of the skill itself.
No, it's deeper than that.
It's practicing the skill while also practicing the emotional regulation needed for that skill.
Exactly. You're forcing that entire loop, task execution and emotional management, through repetition involving the thalamus.
Can you give us a comparison? Make it a bit more tangible.
Absolutely. Think about, say, a surgeon learning a complex new procedure. They don't just read about it. They practice the physical movements again and again. Repetition.
Right. Simulators, practice labs.
Exactly. Until the motor actions become fluid, precise, almost automatic. TCR applies that same physical training principle to emotional resilience. By repeatedly facing difficult tasks, maybe simulations, maybe real-world challenges, and consciously controlling the frustration or anxiety that comes up. You physically build up that emotional discipline. You strengthen the specific neural pathways in the basal ganglia and related circuits. This increases resilience and focus during performance.
Okay. So we've got the wiring, the neuromotor pathways, and we've got the training method, that's cycloside rehearsal. But every engine needs fuel, right?
Right.
Something has to power this whole neuromotor machine. What's the energy source here?
Well, according to these sources, that's where our emotions themselves come in, but viewed in a very specific way.
How so?
They're seen as forms of energy, immediate energy inputs for knowledge processing. And they profoundly influence our attention, our decision-making, pretty much instantly.
So when a strong emotion hits excitement, fear, whatever, it triggers that chain reaction we know about. The thalamus for relay, the amygdala for sort of threat detection,
Emotional significance.
and the prefrontal cortex trying to manage it all, make decisions.
Exactly. Those regions handle initial assessment, sustained attention, planning. But if those circuits get overloaded by uncontrolled emotional energy,
The whole system stalls.
the entire motor learning process could just seize up. Focus breaks down, performance suffers.
And this emotional energy, it directly impacts the brain page development you mentioned earlier.
Yes, absolutely. It translates directly into how strong or weak that brain page, that actionable knowledge structure becomes. Let's look at positive energy first. The sources detail how things like genuine curiosity or enthusiasm for a task, they don't just feel good, they physically trigger dopamine release.
Dopamine, the reward chemical.
Exactly. Specifically in the mesolimbic pathway, which is key for reward and motivation. This dopamine hit acts like a physical reinforcement signal.
So it tells the brain, hey, this is good, remember this.
Precisely. It reinforces memory formation, locks in engagement. It's like the brain physically rewarding itself for effective learning, makes the brain page stronger, more accessible.
Okay, but what about the flip side? If the energy input is negative and crucially unmanaged.
Then the system can start to fail. Unmanaged anxiety or anger or frustration, it doesn't just make you feel bad, it actively disrupts hippocampal encoding.
The hippocampus, that's vital for memory, right? Transferring experiences into long-term storage.
Absolutely vital. If that encoding process is disrupted by overwhelming negative emotion, the formation of that usable brain page structure is weakened. Or it might not form properly at all.
So managing your emotional state, your EI, is actually a strategic physical step to ensure that learning actually sticks and becomes usable.
That's the argument. It's
Well,
about optimizing the physical conditions for effective, self-directed learning and performance.
so let's pull this together for, daily life.
Yeah.
What's the ultimate goal here? The sources talk about achieving balanced living. What does that mean in this context?
Balanced living here means achieving a kind of synchronization, a harmony between the brain's three major systems.
Which are?
The cognitive system, basically thinking and reasoning. The limbic system, feeling, emotion, motivation. And the motor system, the actual doing, performing actions.
Thinking, feeling, doing.
Exactly.
Yeah.
Getting those three to work together seamlessly. That's presented as the real-world outcome of developing this neuromotor type of emotional intelligence.
And the payoff for achieving that balance, that synchronization.
The big payoff, according to these sources, is adaptability. But again, defined physically.
Not just being flexible psychologically.
No. Adaptability here is framed as tangible neuroplasticity. The brain's actual physical ability to quickly rewire its circuits, to literally change its structure to meet new, unexpected challenges.
Wow, so that emotional stability, the calmness you've trained through, say, cyclizide rehearsal, maintained by the thalamus and basal ganglia.
Right, the train stability.
That physically allows you to shift your attention, reframe a setback, and respond effectively without losing motor control or freezing up.
That's the idea. You can reorient quickly. You don't get stuck in the emotional reaction. The stability allows the cognitive and motor systems to adjust rapidly.
And if we tie this back to concrete performance again.
Yes, let's do that. Think about high-stakes professions. If emotional stability is an automated motor skill,
Like we discussed with the basal ganglia.
exactly, then maybe a surgeon is less likely to have a hand tremor during a critical moment. Or a pilot maintains precise control during sudden severe turbulence.
Because the emotional response doesn't hijack the motor system.
Right. The emotional response itself becomes part of an embodied action of adjustment. Internal energy gets converted smoothly into purposeful, controlled external performance, whether that's fine motor skills, complex problem solving, or even just clear communication under pressure.
That's quite a shift in perspective. And the sources actually provide a real-world example of this in practice. You mentioned the Takshila Happiness Classroom.
Yes, they do. And it's fascinating because it's not just some, let's all feel good program. It seems specifically designed to train these neuromotor circuits for emotional control.
How does it work?
Well, it integrates emotional regulation directly into the structure of learning. It functions like a miniature society, a peer learning system.
Peer learning.
Yeah. Older students, or maybe just those more developed emotionally, act as small teachers. Their role isn't primarily academic instruction.
What is it then?
It's to guide the emotional responses of their younger peers during learning activities, collaborations, even conflicts.
Huh. So how does that specific interaction, being a small teacher, translate into building that neuromotor discipline we've been talking about?
Well, think about it. By taking on that role, the older students are constantly actively forced to practice self-control and empathy.
Not just think about it, but do it.
Exactly. They have to do it through controlled motor execution. Things like maintaining a calm tone of voice, even if the younger child is upset, using specific, calming gestures, framing problems neutrally, not emotionally.
So they're basically performing that cyclizide rehearsal, but socially.
That's a great way to put it, yes.
Yeah.
They're repeatedly practicing the motor actions of emotional regulation in a real dynamic context. This strengthens the physical pathways for things like cooperation, patience, focused communication. Emotional stability becomes a required action for fulfilling their role.
That's a really powerful model. It seems to build those three classic pillars of EI: self-awareness, empathy, self-motivation, but all grounded in this idea of physical motor control.
That seems to be the core concept. Ultimately, managing EI through this kind of neuromotor framework aims to produce a disciplined performer.
Someone who doesn't just understand things.
Right. But someone who can act effectively based on that understanding. Someone who turns learning into focused living and emotion into controlled, excellent performance.
Okay, so let's recap this journey quickly. We started with EI as a soft skill and landed on it being, well, a hard science, a science of motor control, focused learning, brain wiring.
Yeah, quite a shift.
Emotional intelligence, viewed this way, is really about mastering your internal world, that whole complex neuromotor system.
Right.
Specifically so you can convert your internal emotional energy into purposeful, effective action out there in the external world.
Well said. And the sources really suggest that true human excellence, maybe even happiness, is defined by that harmony, That's synchronization between our emotions, our thoughts, and our actions.
Transforming learning into living.
And emotion into excellence. That's the essence of it, the art of turning emotional energy into purposeful action.
Which leaves us, and you, with maybe one final thought to chew on. Tying back to that idea of cyclizide rehearsal.
Training like a muscle.
Exactly. If emotional discipline really is strengthened like a muscle through that kind of physical, mental repetition of tasks, what's one conscious mental or motor action, maybe a specific daily routine, or a way you react to a common frustration that you could practice?
Intentionally.
To start rewiring your brain for that calmer, more focused, maybe even autopilot state.
Yeah. What could you rehearse daily?